Now, why we want to know this? Because if a series is convergent, that has a meaning. Means it is summable. You can add it. You can add the sum up. So if you have a computer, right, you can write a program for it, because computer is very good in doing routine mechanical things. So if you know the general term, what general term looks like, you can write a program for it. Just keep adding terms. Because the speed of electron is the speed of light, so it's so fast. The way when you put in the general term, it gives you the answer right away. Because the speed is so fast. Anyway, so if a series is convergent, that means it is summable. So that means if you write a computer program for it, you see the result. You see that there's a number coming out. Okay? And only convergent series is useful. Okay, it's applicable. It's applicable. So it is very important for us to know whether a series is convergent or divergent. Alright. So let's look at 8.3. So now we're going to section 8.3. Okay. Alright. Infinite series. You see that? It's all here. Everything here is just sum. All this sum, right? You see sum. Adding things up. Summation. So infinite series. See the title. Infinite series. That means you add them. There are infinite many terms that you add them up. Okay? Alright, any question about this 8.3?
Yeah, can you use 63? 63?
33?
63. 63.
63. Let me see. Okay, I said so much. Oh yeah, I did send that many. Okay, let's look at 63. Alright. So here's 63. Right? So I have summation k from 1 to infinity. 1 over k plus p plus 1, where p is a positive integer. Okay, so what we need to do is to use partial fraction, right? Partial fraction. So k plus, so that's for general term. K plus p plus 1. I want to write this. And I don't know what I need to find out what they are, A and B. Okay, so I'm going to multiply both numerator and denominator by this denominator, so I get 1 equals A k plus p plus 1 plus b k plus p. And I want to find out what A is, right? I can just use it here. So I say if I let k to be negative p, so this is 0, right? And so 1 equal to negative, oh, A. So A is 1. If I let k to be negative p minus 1, this term, so it's 1, now this term drops out, 0. And k times minus p minus 1, right? So p cancel, so minus 1. So 1 equal to minus b. So b is negative 1. So what I get is, what I got, let me put it here, is that 1 over k plus p times k plus p plus 1. See, a is 1, right? 1. K plus p. V is negative 1, so it's minus k plus p plus 1. So this series is really this series. Now let's see what they ask us to do. Okay? So for this category, then this is called telescoping part of problem. So it says the following. For the following telescoping series, find a formula for the nth term of the sequence of partial sums. So find the nth partial sum as S of n. Then evaluate limit Sn to obtain the value of the series or state that the series diverges. Okay, so I need to find the nth partial sum. Now, what is the nth partial sum? Nth partial is the sum of the first n terms. So, okay, so it's sum k from 1 to n of this. Alright, so what is this? So when k equal to 1, 1 over k plus 1. When k is 1, I'm sorry, that's 1 plus p. And that's 1, so 2 plus p. Okay, that's first term. And you keep writing, so the second one, that's when equal to 2 plus p minus 2. 3, right? And then the next one, k equal to 3. And so on. Okay? So each one of these, so this is k equal to 1, k equal to 2, k equal to 3, or for you continue. Well, if I look at this, I know that this and this can cancel. This and this can cancel. Okay, and you keep doing. Now, the last term is when k equal to n, so it's 1 over n plus p minus 1 over n plus p plus 1. Okay, it's all the way there. And then you see that the second term of the first term cancels the first term of the next term. Right? This cancels with this, this cancels with this, this cancels with this, and then so on. So as you can imagine, the second term of the term before this cancels this term. So you end up with 1 over 1 plus p. All these will cancel out except this one. Minus 1 over n plus p plus 1. This is S of n. Then they want us to take limit of this. And because here they say, after they want us to what? For the following telescoping series, find the for the nth term, right? Or the partial sum, nth term partial, which we have just done. Then they want us to take limit of this. Okay, so this is what I just got. S of n is equal to this. So I'm going to take limit of this. Limit Sn Well, when n goes to infinity, and this n goes to, but then 1 over n plus 7 that goes to 0. So the final answer is 1 over 1 plus p. Okay, and so this is the limit of this. So this is where the series converges. So therefore, the telescoping series converges to and therefore, because this is what the nth partial sum converges, yeah, so the series converges with. So find it and to obtain the value, yeah, so the value of this series, therefore, the value of the series equal to 1 over p plus 1. Okay, so that's the answer. Any question? Any other question? Yes?
37.
37. Okay. 7a, and this is 9. 37. Alright, so summation, there's a 3 here. K from 0 to infinity. Negative pi. Negative k. Whatever geometric series with alternating signs. Oh, okay. Evaluate it. Yeah, I want to find that. Yeah. Okay, they give us a hint. Now, but before we do it, let's recall what geometric series is. Okay. So geometric series looks like I'm summing a to the k. K can from 0, from 1, from whatever. Okay. So let's say k from say k from 1. Okay. K from 1. Let me write this. Let me use R, okay, because we always use this notation. Yeah, we use this R. Okay. So k is from, let's say, from 0. Okay, so this we know that it is what, equal to 1 over 1 minus R. If R is less than 1. And then for this one diverges. This one diverges if R is greater than 1. Okay? This is the geometric series. The theorem you have to know. This is in the book as well. Alright, so if I want to use this into here, right? So how do I use this into here? So I'm going to rewrite this, right? So it's 3. And this is like like 1 over minus pi to the k squared.